Now this question is a very interesting question, and there's one or two concepts that you will actually learn from this question. A concept that we actually already touched upon in one of the previous questions, but we'll have a much better grounding of how to tackle these kinds of questions in your exam. Now it's given that you are numbering, as per the question, you are numbering houses starting from house number 1 to house number 319. Now, how many digits in all are you actually using when you're counting numbers from 1 to 319? So let's look at it this way. You're starting with single digit house numbers. So you have house numbers from 1 to 9, which are the single digit house numbers. And how many such numbers do we have from 1 to 9? You have 9 such numbers. Each number, each house number is using exactly 1 digit. So 9 houses are using a total of 9 digits. Now let's come to the 2-digit house numbers. 2-digit house numbers start from 10. They start from 10, they go on to 99. So from 10 to 99, how many numbers do you have? You might be tempted to say 99 minus 10, you have 89 numbers. But remember that if you are counting, remember this as a simple concept. If you are counting numbers from A to B, it means that A and B both are included in your count. So the number of integers from A to B would be B minus A plus 1. You might want to try it for yourself with much simpler numbers. If you're counting numbers from 3 to 7, so how many numbers do you have? You have 3, you have 4, 5, 6 and 7, you have a total of 5 numbers. So that's nothing but 7 minus 3 plus 1. So you have 5 numbers. If you are counting numbers between A and B inclusive, if that is the kind of terminology the question uses, it simply means numbers from A to B. So both mean the same. But if, let's say, the word between A, the term between A and B is used, but inclusive is not used, it means that you are actually excluding A and B. So if let's say you're counting numbers between 3 and 7, so you have 4, 5 and 6, only 3 numbers. So how do you get that value? That's nothing but B minus A minus 1. So here, if you're counting numbers from 10 to 99, how many numbers do you have? 99 minus 10 plus 1. So 99 minus 10 is 89, plus 1 is 90. So you have a total of 90 houses. Each house requires 2 digits, so 90 of them require a total of 180 digits. Come to the 3-digit numbers. 3-digit numbers are starting from 100, you are counting till 319. So how many houses are you counting here? 319 minus 100 plus 1. So 219 plus 1 is 220. So 220 houses is what your count is. Each house now requires 3 digits to number. So 220 of them would require a total of 660 digits. So what is the total number of digits that you are using to count numbers, houses from 1 to 319? So that's nothing but a sum of all these values. That's 9, 4, 8. So you have used a total of 849 digits. So the key takeaway from this question is actually being able to count numbers within a range and from a number to another number. So this is an extremely important point that you have to keep in mind. Your next question says that if R and S are integers each greater than 1 and 11 times R minus 1 equals 13 times S minus 1, what is the minimum value of R plus S? Now, since it's given that R and S are each both greater than 1 and they are positive integers, you obviously cannot come to the conclusion that R and S R plus S minimum value is 2 when you take R and S as 1. That's not possible as per the question because they are greater than 1, and also logically it's not really possible because if you write this number as 11 times over let's say S minus 1 equals 13 times 13 over R minus 1, the equation can be written this way. So if you write it this way, if R and S take a value of 1 each, it means that your denominator is a 0. That's not possible. So which means R and S cannot be 1. So they have to be something else. So what else should that be? So this is not possible. So what else? How do we solve this question? If you treat this question as one equation in 2 unknowns and try to solve it for the values of R and S, then you have definitely fallen into the trap. Now this should not be a conventional approach to actually solving these kinds of questions. Pick up clues from the question itself and see how you can apply the information given in the question to actually solve such a question. 11 times R minus 1, so this is a multiple of 11, equals 13 times S minus 1, so this is a multiple of 13. So a multiple of 11 on the left hand side equals a multiple of 13 on the right hand side. That should be a first observation that you make. Moreover, 11 and 13 both are primes. Automatically they are co-primes to each other. Now how do we use that information? So here we are saying 11 times some value A equals 13 times some value B. That's what we are saying. So 11 multiple equals a 13 multiple. How is that possible? That's possible when 13 actually equals the value of A and B actually equals the value of 11, or A should be some multiple of 13 and B should be some multiple of 11 such that that multiple actually gets cancelled out, or in other words what we are saying is this: if A equals 13 and B equals 11, so A is nothing but R minus 1, so R minus 1 is 13, so we are saying R is 14. Likewise, S minus 1 is 11, so we are saying S is equal to 12. So R plus S minimum value here is 14 plus 12, it is 26. That is actually your answer. Now, why should it be such that R is only 14 and S is only 12? Remember, we are actually finding the minimum value. So here, when you are saying that A equals 13, A doesn't have to equal the value of 13 alone. It can be some multiple of 13 also. So 11 times some multiple of 13 equals 13 times that multiple of 11. So that common factor that you have on left hand side for A and right hand side for B gets cancelled out. Only when it gets cancelled out will you be able to minimize the values of A and B. So that's precisely why we are saying that A takes 13 and B takes 11. So this question is a fairly simple question, but it's just made to look tricky. Now the next question has given you information about a number in the form of a set. So you're given that n consists of all numbers of the form n over 13 such that n is a positive integer, and GCD of n in 13 is 1. GCD is again nothing but your highest common factor HCF. N is less than 26. So number one, positive integers less than 26, which means you will say n will take values from 1 to 25. Now, remember that there's also one more clue that says greatest common divisor of n in 13 is 1. It means that n and 13 should be co-primes to each other. So all these values in this list of n will satisfy except for 13, because GCD of 13 and 13 is actually 13 itself and not 1, which means we are technically not supposed to be taking 13 as a value for n. So in other words, your n consists of all these numbers like 1 over 13, 2 over 13, 3 over 13, like this. We do not include 13 over 13 up to 25 over 13. Your question says, what is the sum of all these numbers? Now, for simplicity's sake, because all these numbers have the same denominator, and 1 to 25 would actually be consecutive integers, and we have a formula to find the sum to the first n positive numbers, what we will do is we will include 13 over 13 also, and from the result we will eliminate this value 1. That should be your answer to the question. So this is nothing but 1 over 13, sum of the first 25 numbers would be 25 into 25 plus 1, that's nothing but n into n plus 1 over 2. That's your formula to find sum to the first n integers. I'll write it here. So this value is n into n plus 1 over 2. That's your formula to find sum to the first n numbers. So this is your answer, but remember this answer has included the number 13 by 13, 1. So we will subtract that value 1 from this. So 13 into 2 is 26, gets cancelled out. So 25 minus 1, effectively we have 24 as your result. So the answer to the question is not 25 but 24. The next question says that if 2/3 the number of women attending a dance is equal to 1/2 the number of men attending the dance, then what fraction of the total number of men and women attending the dance are women? So in other words, your question says W over W plus M is how much? What fraction of the total number of men and women attending the dance are women? That's your question. So in other words, you have two unknowns in this expression and you have an equation that can relate one unknown in terms of the other. So all you have to do is you have to convert one of these in terms of the other. So we will keep the w as such and we will write m in terms of w from this first equation. So here m is nothing but 4/3 of w. So we will write the value of m as 4/3 of w in this expression so that your w gets cancelled out. So what you get is 1 over 1 plus 4 upon 3. So this is nothing but 3 upon 7. So effectively what we are saying is the number of women attending the dance to the total number of men and women attending the dance is in a 3:7 ratio, or this is a 3/7 fraction. So this should be your answer. So these are the different kinds of basic questions that you need to be acquainted yourself with in terms of the skills being tested in your exam. But then again, this is just not limited to these questions. Once you move on to the exercise part for yourself, you will see that there is a much more wider variety that you will be tested upon, that you could be tested upon, and concepts that you need to be able to apply on such questions in the topic called numbers.